Hello everyone, this is Srikanth, working as assistant professor in electrical department. In this video, I want to discuss about course description. What is the course objective? What is the course outcomes? Course overview. So we will check it one by one in this video. Coming to our course, that is electrical circuits, and the code is AWC02. This is for second semester, guys. BTech second semester, and as well as regulation is IARE R20. And we have 3 credits for this subject, and for this subject we have laboratory also. So for that laboratory we have 1.5 credits. Okay, and this course is some related to our physics. In first semester we have the physics. For that physics, somewhat related to that physics subject. For this subject we have 70 marks, that is external, and internal 30 marks. Total we have 100 marks. For electrical circuit we have 100 marks. In that, internal is 30 marks. For internal is 30 marks and external is 70 marks. Coming to overview, so this course, which course we have electrical circuits, is fundamental to all subjects. So this course includes some magnetism, AC as well as DC. So fundamentals of AC, DC circuits, and power, resistor, capacitors, of which elements we have different elements, and some analysis, circuit analysis, as well as theorems, and two-port networks and network topology we have in this subject. So this course, if you know this course, so we'll get like real-time applications. So in your home, we require some voltage. So how much voltage you want? How much power you require for your home? Not only home, in industries. So it's like real-time applications. For real-time application, we require this subject. So coming to course objective, so we'll get some knowledge. So from this course, you can learn network reduction techniques like mesh analysis, nodal analysis, star to delta, delta to star, equivalent resistance. All those things you can learn in this course, as well as basic concept of AC circuits. So I said like in your home, we require some voltage. So in your home, you are getting like AC supply. So how much you require, and how you get those current and power relationships. Magnetic circuits. So as well as we'll learn about magnetic circuits and two-port networks. So this is about the course objectives. We can get some knowledge on these topics. So we have like electrical circuits. In that we have some overview, then some objective. So from our college, we have one type of syllabus. For another college, we have different type of syllabus. So different type of names, like FW, otherwise BW, EW. So something different names we have. In that syllabus also, we have different types of like topics we have. So in NBA, so NBA like done some magic. For every college, need to get some like outputs for students. So they have different subjects. So don't worry about the different subjects. But at last, the result for each student from each college will get like same result. So that is outcome based education. So NBA given some guidelines to each college. So they need to go for the outcome based education, like OBE. So outcome based educations have like 4 levels. First is so program educational objectives, POS, and program outcomes, program specific outcomes, as well as course outcomes. So we have like 4 levels. So first one, program educational objectives. So program educational objectives is decided to like department HODs. So for each department, then they have like different POs and program outcomes. So that is decided by NBA. So NBA decided like program outcomes to each college, and program specific outcomes. This is like again departments. So each branches, not department, you can say like each engineering divisions we have like program specific outcomes. And coming to course outcomes. So course outcomes is decided to each faculty. So each like a lecturer, they want to decide like how many program outcomes we have for each course. From each course, they decide like some different program outcomes. Okay, so we'll check it one by one now. So program education objectives are, we have like 4 for our college. We have 4 POs. So first one is success in electrical engineering. So every student need to success in our electrical engineering. Second PO, industrial awareness research. So when I get like some graduate, some degree, then some knowledge, I will get some knowledge in industry as well as research. And as well as we have success employment. So we need to get like success employment and personal ethics. So in general, in any way, I have like graduate means I require some knowledge on industries and some research. I will get some knowledge and some employment. Without employment, you can't live in society. Some ethics also. We require some ethics, personal ethics. So we need to learn all those things. And we have one more. That is the fourth one is leadership. So leadership is very, very important. So in any employment or any place, so you need to show to others like bold. Clear. So these are some POs for electrical engineering. Then coming to program outcomes. So program outcome decided to NBA. Here we have 12 program outcomes. So just observe clearly, we'll get why this program outcomes. So for each course, we require some outcomes. So first one is engineering knowledge. So basic knowledge we require for our course, each course. And coming to problem analysis. So some courses are total theory, so English. So total theory. So like this, we don't have any problems. But in electrical circuits or any electrical engineering subjects, maximum we have some problematics. Okay, so problem analysis we require, and design and development. Suppose renewable energy system is there. So in that we can design some models. Okay, coming to fourth one, so like complex problems. So some courses have like complex problems, and we have like model tools. So some courses have like model tools, mechanical, and in EEE also we have like model tools. Coming to sixth one, so the course is so useful to engineers as well as society. And seventh one is the course is related to environment, and eighth one is ethics, and ninth one is individual and teamwork. So depending upon different courses, so all these POs need to attach, so need to connect. Suppose I have a course, for that course these 12 POs, program outcomes, need to connect. So for suppose mathematics subject is there, so we require some knowledge and some problem analysis, complex problems also. So depending upon different. Suppose a renewable energy system is there, we require designs, and some environment subject is there, we require the environment as well as ethics. Okay, and communication, like English subject is there, we require the communications, and MBA subject is there. So there we have the project management as well as finance, and some subjects related to lifelong learning. So basic subjects we have for lifelong learning. Okay, so these are the program outcomes for each courses. So from different courses also, the outcomes is these 12. These 12 are main outcomes for each course. So particular subject we related to like knowledge or a problem. So like that we have like 12 POs for different courses. Next, coming to program specific outcomes. So this is like depending upon engineering. So different engineering stream, we have different program specific outcomes. So this program specific outcomes we have like 3. Okay, so for 3 also related to our subject. So electrical subject means, so depending upon the electrical engineering means depending upon the electrical circuits. So just observe here, we have like electrical generations, power generation, transmission, distribution, utilization. So these are the one PSOs. And here if you observe here, we have like so electrical devices, okay, energy conversions and applications on industries. So these are some related to our electrical engineering. That is one of the PSOs. And third one is so like skills developments. So different automations. So those are PSO 3. So these are like 3 PO. So these 3 POs, so this 3 PSOs for electrical stream. Okay, and coming to course, so we have like 5 different models. For each different models, I have different course outcomes. So the first module we have different topics. Okay, so for this first module, I have like 3 course outcomes. So for this module, so first module I have 3 course outcomes. Now coming to topics, so topics related course outcomes. Topics related. So from the topics, which outcomes I will get? So from that module, how many outcomes I will get? Like student will learn. Okay. So coming to topics, we have Ohm's law and classification of elements, independent dependent sources, and voltage and current relationship. This is a basic like topics. Coming to AC also we have in first module. In first module we have the AC also. In that, so how to represent like alternative techniques and different periodic waves and phase difference and impedance and admittance as well as AC power. So total AC circuits. Okay. So from this topic I have 3 outcomes. So from these topics I can get like some characteristics on DC as well as AC networks, electrical networks. And one more outcomes is I can get some laws that is like Ohm's law and like some different techniques. So from that Ohm's law I will get like some network reduction techniques. Okay. And third one is we have DC as well as AC also in that first model. So we can get some knowledge on alternative techniques. Some knowledge on alternative technique like peak, average, RMS values. Coming to second module, we have source transformation and Kirchhoff's laws and equivalent resistance, inductance, capacitor like total passive elements and star to delta, delta to star technique, mesh analysis, nodal analysis and inspection method and super mesh, super node analysis. Now from this module I have some outcomes. So same thing, we'll have some laws here. So I will get some different laws concept and network reduction techniques, star to delta, delta to star and equivalent value. So all those things comes under network analysis, network reduction techniques. So from this module we have one more course outcome, that is branch currents or nodal voltage indirect techniques. So which we have like mesh analysis and nodal analysis. Okay. So this is our 4th course outcome. And coming to third module, we have DC as well as AC theorems. So DC as well as AC theorem, in that also intelligence, superposition, reciprocity, Norton's, Thevenin's, maximum power transfer theorem, Milliman's theorem, compensation theorem. So here we have 8 different theorems. Now coming to theorems, we have prove. So superposition need to prove, intelligence theorem need to prove, so reciprocity theorem and maximum power transfer theorem. So these are some theorems. We know some logic on that theorems. We have some logic and some concept. And coming to Thevenin's and Norton's theorem as well as Milliman's theorem, these are you can some network reduction. So we have like big circuit converted to single circuit. So there are also some logic, but some different processor. Okay, we have AC as well as DC excitation. Not only AC, not only DC, but we have both excitation in this module. So here we have 2 outcomes. So this is about third module. And coming to fourth module, we have so Faraday's law and self and mutual inductance, dot conversion and coefficient coupling and some composite magnetic circuits and analysis of series parallel magnetic circuits. So this is like some basic topics, so which are related to our physics. So in the physics also we know some logics. Okay, and here we have again 2 COs, course outcomes. 2 course outcomes here we have. So one is recall. So we need to recall some Faraday's law and about magnetic circuits. Okay, and coming to one more course outcome we have here, that is remaining topics. So which topics we have like coefficient coupling and composite magnetic circuits, those analysis. Okay, that is about course outcome 2. So from that course outcome we have like these topics. And coming to 5th module, here we have 2 topics. One is 2-port network and network topology. From this 5th module we have 3 course outcomes. One is depending upon like 2 port parameters. So from this 2 port parameters, what you gain? Okay, and one more CO, that is depending upon your network topology. So from that network topology, so what you gain? And next, one more topic we have, that is network duality. From this network duality, what do you gain? Okay, so this is about like course outcomes from our syllabus. So we have 5 modules. From 5 modules, we have 11 outcomes. Course outcomes, we have 11. So actually, we have outcome based education. So like OBE. So for that OBE, I have like 4 steps. One is POs, one is POs, and PSOs and CO. So I have 4 different steps. So I need to connect these outcomes, course outcomes, with your program outcomes. So I need to connect with course outcome, I need to connect with program outcomes as well as program specific outcomes also. So we'll check it now. So for that, I required Bloom's taxonomy. So Bloom's taxonomy I required. So in that, we have 6 steps. Those are remember and understand, apply and analyze and evaluate as well as create. So like each step we have different meaning. So remember means like in our course we have like Faraday's law, Ohm's law, Kirchhoff's law. Those are related with the like recall, like remember. Okay, I need to remember those topics. Okay, coming to understand some analysis like star to delta, delta to star, and mesh analysis, nodal and theorems. Those are I need to understand those topics. Okay, apply. Okay, star to delta we have the star to delta topic need to apply to some different place. So different place, that is network technology course. I can apply those topics. So there I require some apply conditions and analyze. Analyze more again. So remember is recall, like I can get some knowledge. I want to recall my knowledge which you have already. And understand, I need to understand some topics values, some topics ideas, and coming to apply. So I need to solve those problems on different places and apply those values. And analyze means like we need to examine. So we have some different topics. Again, I need to add some different analyzations and evaluate. So which value we have. So some analysis. From that, we need to evaluate those values. Okay. And last, we need to create. So this is like again big. So after analyze, evaluate, then we need to create some project, some research. So all those like 6 topics. So 6 steps we have here. So all those related to our outcome based education. So this 6 is related to our outcome based education. So we'll check it those relation. So suppose I want to create some question. Okay, I have like OBE system. For this OBE system, so we have one question from this OBE system. I have one question. That question is related to all colleges. So all colleges. Okay, so I have one question means that question can answer all colleges. Okay, so depending upon this Bloom's taxonomy. Okay, so coming to remember list of electrical networks. Okay, that is one type of question. So again, define the Ohm's law or Faraday's law. Okay, so recall our Kirchhoff's laws. So we have different questions on this remember. And coming to understand, we have like a described, explained, discussed. So these are the questions comes under your understand. And apply. Apply means so calculate, solve, perform. So all those things comes under your apply. And analyze. Coming to analyze, like classify, categorize, analyze. So all those comes under your analyze. And create. Coming to create, we have like justify, judge, evaluate. So these are comes under your evaluate. And create. Create means design, create, develop, generate. So all those comes under your create. So this 6 is related with your outcome based education. So for electrical circuits, we have 11 outcomes. For this 11 outcomes, which is the remember, which is the understand, which is the apply, which is the analyze, which is the evaluate, which is the create. We'll check it now. So first one is So define some concept on your AC and DC. So like you can have like recall those ideas. Okay, that is under remember. And coming to, and second one is we have different laws as well as equivalent values. So there we need some understand. So what is the main like concept on laws as well as equivalent values. Okay, we have comes under understand. And third one is we have AC circuits. So in that AC circuit we have different periodic waves. There we have like some concept. So we have under remember. So we need to remember those concepts. So fourth one is indirect techniques. So indirect we need to discuss some on indirect techniques. So there under understand. And the fifth one is again AC as well as DC. So we have the alternative two courses, AC and DC theorems. So for AC theorems and DC theorems, we have like some discussion and some summarized, some like deduction techniques. So those two are comes under understand. And coming to fourth module, we have like Faraday's law and composite magnetic circuits. So these two, one is like Faraday's law is from physics we have, so same which we have, same thing we have the remember, and so composite circuit. So some we have need to understand. We need to understand some logic on that composite magnetic circuits. So coming to fifth module, we have two-pole network. So two-pole network means we need to get some problems. So we need to understand those problems. Okay. So that is comes under understand. And remaining two topics. So like network topology as well as duality. So no need to go for like some problems, some analysis, but here we can understand. So we need to remember. So we need to remember those topics. So those comes under remember. Okay. If you observe that levels, which level we have. So in remember, we have the 5 points, and understand we have the 6 points. So in total, we have 5 remembers we have, and this 6 is understand. So this is like fundamental subject, basic subject for each branches. So for every branch, it is a fundamental subject. So it comes under up to understand only, and apply analysis before subjects. So based on these topics, we need to apply in different places, analyze different topics, and evaluate different topics, and we need to create some different equipments. Okay, so this is like basic subject. So we have to remember and understand we have. So this 11 outcomes for we have 11 outcomes. For this 11 outcomes, I need to match with your program specific outcomes. So I need to compare. So which is the best one? So this we have like 11. This 11 is mapped with our program specific outcomes. So how can map? So for that we have 3 program outcomes. I have 3 program outcomes here, and one is program specific outcomes. So program outcomes means we have engineering, problem solving, ethics, environment science. So all those things we have like 12. In that 12, here I have only 3. So in that engineering knowledge, so that is a basic one. Basic subject means I require the engineering knowledge as well as some problem analysis. So we have some problem analysis and some complex networks also we have in that electrical circuit. So I mapped with 3 POs. So which course I have like in that 11. So we have 11 COs. This 11 CO mapped with 3 program outcomes. Okay. So we have total 12. In the 12 I mapped with 3, and specific outcomes I mapped with only 1. So only 1. So why I mapped means some analysis we have here. I mapped with 1 PSOs. So 3 PO, 1 PSOs. Now what is the value? So what is the strength of those POs and PSOs? So here I give like full strength. So POs maximum 3 we have. In that 3 I give full, and PO2 2 and PO4 2. Some topics we have some problems, so I give like 2 to strength. And coming to PSOs, I give like 1. In the 2 I give like 1. So this is about some strength. And here we have like which method I need to get those outcomes means CIE 1. So like internal exams, quiz exams, and AAT exams. So under this, so I will get some outcomes. Now coming to, so I will compare those course outcomes and program outcomes means, see we have 11. In that 11, maximum 5 remembers and 6 understand. Now 5 remember, 6 understand we have. So remember means maximum we require the engineering knowledge. Okay, understand means we require some analysis. Same thing here also analysis. So where we have like a, where I want to recall which course outcome I need to recall, there I require the engineering knowledge, and where we have the analysis, there I require the PO2, PO4 and PSO1. Okay, so I need map. So which course outcome? So this course outcome is, we have suppose CO1. CO1 means remember means like some idea about AC and DC networks. So some idea on the AC and DC networks. So for that I require, and some problem means we will go for the PO2 also. So PO1 is necessary, but PO2 is small. So for this, how many keywords need connected? And for this PO2, how many keywords need to connect? We have different keywords also for each POs. Okay, same thing CO2. CO2 means like a maximum we need to find out that some analysis we have. So for that I connected with PO2. And CO3 we have like basic knowledge on your AC, sine wave, like different periodic waves. So I connected with engineering knowledge. And PO4, CO4 are like we have some problems. So I connected with PO4. Okay, so some complex problems we have, so I connected with PO4. So like that we have 11 COs. This 11 CO connected with one program outcome. So which I selected from 12 I selected 3. These 3 connect to one COs. Okay, we'll check it now. So my 11 COs connected with PO1, PO2 and PO4 as well as PSO1. So this 4, so which course outcome? So we have 11. In the course outcomes, 1 is connected with PO1 and 2, and course outcome 2 is 1, 3 also 1 and 4 also 1 and 5 1. So I have like connected to each. So depending upon our topics. Now coming to keywords, so how much strength we have? So we have like, I selected like 4. One is PO1, PO2 and PO4 as well as PSO1. So for each program outcomes, I have some keywords, some key components. So for PO1 I have 3, PO2 I have 10 and PO4 I have 11. Okay, and PSO2 I have 2. So for each POs I have different key components. Okay, so for each COs, so we have 11 COs. For each CO I mapped with some different POs. So PO1, PO2, PO4. Now how much key components connected with this CO? So I have CO1, we have like PO1 and PO2. So PO1, how many key components do we have? PO2 also, how many key components we have? So just observe here and get the values. So I given the 3. So we require 3 components to CO1, and here I have the 5. And same thing we have like for each understand each remember I have like PO1. So for PO1 I have full strength. So full keywords key components I require to my POs. And coming to CO2 I given like different values. So depending upon our CO and POs. Okay, then we need to calculate the percentage, how much percentage we have from each course. So here we have 3 out of 3, so 100. So here 10 out of 5 we have like 50, 10 out of 4 we have the 40. So how much out of we have? Just get it. So here 5 out of, so 11 out of 5 means we have 45.5, 45. Okay, 11 out of 5 means again 45.45. So how much percentage will get from those CO and PO mapping? Okay, so this is about like percentage. Now coming to topics. So for this course we need to divide like 40 theory topics and 15 problematic topics So in the theory also we need to cover like theory as well as problem. This 15 problem, only 15 to 20 problem comes under different problems, which you have like general previous question papers are different complex problems. And coming to one more definition terminology, we have like 5 topics, and one more 5 topics is question banks. So we need to go for the different question banks and get the some topics for each module, one topics. So this total 65 to 70 topics. We have videos also, and this is about like course overview and program outcomes and outcome based education. Okay, if any queries, comment in comment box, and please watch my videos. We have like the 65 videos on this electrical circuit course, so please watch my videos. If any queries, just comment in comment box. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.